that is called as a random variable. The capital X equal to some 4, 5, 6 numbers only. I want the information. What is that 4, 5, 6? Getting of the die number 4, getting of the die number 5, getting of the die number 6. That is called as a random variable. Random variable for particular values. Next, it is a random variable. Is a notation is denoted by capital X is a S to R. Is called as a random number. That is, the values are defined by the capital X. It is defined as a sample space of S. Sample space of S in a random experiment. What is a random experiment? Any experiment can do repeatedly. Possible number of availabilities are known well in advance, and the total favorable cases is known well in advance. What is the particular objective of getting that is we don't know well in advance? Then it is a random variable, means it is a experiment can do that repeatedly, and total sample space is known well in advance, and on the random experiment, and we don't know particular favorable of random experiment what we can get. These three will be satisfied. That experiment is called as the random experiment. In the Bernoulli random variable, means it is a either we represent either zeros or ones. That is called as a Bernoulli random variables. Next, it is notations of, means it is a capital X probabilities. Always we have to be observing this in that it is a probabilities of random variable. So P of X equal to X. That is a capital X of W equal to X. P of X is less than or equal to A, means it is minus infinity to A. And P of A less than capital X less than or equal to B, means it is a P of W, and X of W belongs to A comma B. Then P of capital X equal to A or X equal to B, that equal to P of bracket of X equal to A union capital X equal to P of capital X equal to A and capital X equal to B equal to P of capital X equal to A intersection capital X equal to B. Discrete random variable. Types of random variable. The random variables are classified into the two types. It is the discrete random variable and continuous random variable. Discrete random variable. If the random variable capital X takes at most a countable number of values, it is called as a discrete random variable. In other words, it's a real number of it is a real valued functions defined on the discrete sample space is called as a discrete random variable. A random variable are classified into two types. It's a discrete random variable or continuous random variable. Discrete random variable, if the random variable capital X takes at most countable values, it is called as a discrete random variable. Example means it is a, already I mentioned that it is a, when we are taking the random variable is a discrete, means it is a, for example, the number of the children in a family, it is a discrete count. Number of students in the class, number of accidents per this year, number of heads in tossing of it 2 coins. It is a number of accidents per year. Means every year it will be the counting is a changes, but here range is a changes for the one particular year to another particular year. That kind of observations are called as a discrete random variable. Next, continuous random variable capital X is said to be continuous if it is all the possible values between the certain constant. In other words, the random variable is said to be a continuous when it is a different values cannot be put into the one-to-one correspondence with the set of possible integers. Continuous random variable is a random variable that can be measured any degree of the accuracy. Example, the temperature recorded in a town. The temperature recorded in a town. Town will be means it is an entire town will be take the same. Navinton. అయిపోయినా నవీన్తో వెళ్ళి పాస్వర్డ్ జనరేట్ చేసి పాస్వర్డ్ కూడా జనరేట్ చేయించుకుంటే continuous random variable is a random variable that can be measured any degree of the accuracy. Example, temperature means it is recorded in the town. Hyderabad town is any corner if you check we can get that is the same temperature. Next, it is the age of the group of the persons. It is the 18 years means all 18 years will come. Height of the soldiers in the country. It is a particularly 170 or 167 like that. If we have a particular that is a fixed, it will not change into the soldiers. Right. Life of a electrical bulb, it is 1 year, 2 years, 5 years like that. These all are comes to the examples of a continuous random variable. Here, examples, another example, if I take that, it is a tossing of a coin, tossing of a pair coin. Find the sample spaces and the range of the random variable. Range of the random variable. He will ask the question like this. At the time, what is the tossing of a coin? We have a possibilities of the total sample space is 2 only. It is either getting head or tail only. So in a sample space, yes, head or tail. Capital X is a random variable. Capital X, S to R is given by X of H equal to 1, X of T equal to 0. So here, number of heads, capital X equal to bracket of X, it is a X is a H comma T, this tends to 0 comma 1. Range of capital X equal to 0 comma 1, X can take the values of 0 and 1. If we can throw a die, then a random variable is defined as a number of faces, find the sample space and the probability function. If we can throw a die, sample space S equal to 1, 2, 3, 4, 5, 6. So here in the above problem, getting of head is we represent 1 and the getting of tail is represented 0. So these are called as a range. So range of the random variable is a 0 comma H only, 0 comma 1 only. What is the total sample space? It is a getting of head is a one possibility and getting of tail is another possibility. That is called as sample space. Next, another example, we can throw that is a die sample space, yes, 1, 2, 3, 4, 5, 6. And it is considered the random variable capital X, which assigned to the each element of yes, the number of the face of the die. Here, throwing of a die throw chess, then with any faces, sometimes 6 faces. That all are called as a sample space, yes. In that sample space, here ranges if we observe, probability functions if I observe. The range also, what is that? 1, 2, 3, 4, 5, 6 only. So getting a 1, 2, 3, 4, 5, 6, it is a probability of 1. What is it? P of capital X equal to 1, P of 1 equal to getting a 1 number probability. Out of 6, you are selecting only 1. So 1 by 6. Probability of X equal to 2. 2 means it is a number 2 face I want. So for P of 2 equal to how many faces we have in a dice? 2 number is only 1. So that 1 by 6. Here P of 3, only 1 number, 1 by 6. P of 4, only 1, 1 by 6. P of 5, only 1, 1 by 6. P of 6, only 1, 1 by 6. That is only one face having on the die. So that it is a random variable and probability. We can represent this table is called as a distribution table. Now it is a total outcomes. Which one you are selecting? That is a 1, 2, 3, 4, 5, 6 is the total outcome of the sample space. Random variables, so we can choose that one number getting the respective probability P of X equal to 1, X equal to 1 by 6. Getting up to, please.
Sir, how we get P of 2 is equals to 1 by 6? Can you explain me again?
Here die means how many faces we have? 6 faces. Am I right?
Yes.
Yes. Here I want to get the 3 number. How many 3s we have? 1. So that favorable cases are 1. Total exhaustive cases are 6. So favorable cases by exhaustive cases is called as a probability. So favorable is I have only 1 possibility out of 6. So that 1 by 6 is called as a probability. Similarly, I will take the 5 number. 5 numbers, how many we have on the die?
1.
1 out of 6. So that 1 by 6 is the probability.
Okay.
Total outcome is called as a sample space. In that outcome, here I want to select the 1, that probability I can get it. That is called as a representation of here random variable, which one you want to be choose, which number you want. That probability is a P of capital X equal to X. This is an overall idea about it, how the probability representations we can take. Is it clear? Next. Here, throwing up a 2 dice. Tossing up a 2 coins. 2 coins means 2 coins you have to hold on your hands and throw it. 5 minutes. You're throwing up a die. Here, throwing up a 2 coins at a time. Here, one on that I can get head, and another on that I can get head. So H is a possibility. Next is the HT possibility and the TH possibility. TT, both will be the TT possibility. So total sample space is equal to bracket of HH, HT, TH, TT. How many we have? 4 possibilities. Here probability of getting of heads. How many heads we have? two heads. Two heads we have, and one head we have, and zero head. No head we have. So that it is a probabilities is represented that it is a HH, TH, TH, TT. We have a, that is a range is a bracket of here zero head, one head, two head. Two heads means HH. One head means HT or TH. Next, no head means TT. Now this is the range. Probability I'm going to get that P of capital X equal to 0. Here P of X equal to 0 means TT. No head. No head. No head means I have a TT. How many TTs we have? Only one out of 4 sample space. HH, TH, THT, TT. Out of 4, I am selecting only TT. So that it is 1 divided by 4. Next. అమ్మ 2 కాయిన్స్ మీ చేతిలో పెట్టుకొని త్రో చేశారు అనుకోండి. పాసిబుల్ శాంపుల్ స్పేస్ ఏమొస్తుంది? ఒక దానికి హెడ్ పడవచ్చు. ఒక చేతిలో హెడ్, ఇంకో చేతిలో కూడా హెడ్. ఒక చేతిలో హెడ్, ఇంకో చేతిలో టెయిల్, ఇంకో చేతిలో టెయిల్, ఇంకో చేతిలో హెడ్. 2 టెయిల్ పడవచ్చు. అవునా? అది మన శాంపుల్ స్పేస్ అంటాం.
ఎస్ సార్.
టెయిల్ అంటాం అనుకోండి. టెయిల్ అంటే హెడ్ ఉంది అందులో లేదు, కాబట్టి దాన్ని 0 అని పిలుస్తాం. రేంజ్ ఈజ్ 0. నెక్స్ట్ ఓన్లీ వన్ హెడ్ ఉన్నటువంటివి 2 ఉన్నాయి, కానీ ఒకే హెడ్ ఉన్నటువంటిది పాసిబిలిటీ అంటే 1 అని తీసుకుంటాం. 2 హెడ్లు ఉన్నటువంటిది 2 అంటే అక్కడ నెంబర్ ఆఫ్ హెడ్స్ ఈస్ కాల్డ్ యాజ్ రేంజ్ అని పిలుస్తాం. దాని రిప్రజెంటేషన్ 0, 1, 2. నాకు ఈ రేంజ్ కు ప్రాబబిలిటీ ఫైండ్ అవుట్ చేయాలి. ఐ వాంట్ ఐడెంటిఫై ద ప్రాబిలిటీ ఆఫ్ దట్ రేంజ్. అప్పుడు P of capital X ఈక్వల్ టు 0. 0 తీసుకోవాలి. 0 అంటే ఏంటిదమ్మా? నో టెయిల్. శాంపుల్ స్పేస్ లో ఏమేమి ఉన్నాయి? HH, TH, TT, HT. ఈ 4ట్లో మీరు సెలెక్ట్ చేస్తున్నది ఏంటిది? 0ది. 0ది అంటే ఏంటిది? టెయిల్ అంటే నో హెడ్ ఉన్నటువంటిది. నో హెడ్ ఉన్నటువంటి శాంపుల్స్ ఏముందమ్మా? TT మాత్రమే. కాబట్టి ప్రాబిలిటీ ఆఫ్ TT ఈక్వల్ టు మొత్తంలో ఆ TTలు ఎన్ని ఉన్నాయి? ఒకటే ఉంది. మొత్తం అవుట్ ఆఫ్ 4. 4ట్లో ఒకటే ఉంది కాబట్టి 1/4 is the probability. Favorable cases are only 1. Total sample space is 4. So that 1/4. అర్థమైందా?
Yes, sir.
నెక్స్ట్ P of X equal to 1 అంటే ఏదైనా ఒక హెడ్ పడితే చాలు. అటువంటివి ఎన్ని ఉన్నాయమ్మా? 2 ఉన్నాయి. కాబట్టి P of TH యూనియన్ HT అంటాం. ఇప్పుడు P of TH plus P of HT. సో 1/4 plus 1/4 అంటే ఎంతమ్మా? 2/4. 2/4 అంటే ఎంతమ్మా? 1/2. అర్థమైందమ్మా? క్లియర్? P of X ఈక్వల్ టు 1 అంటే 2 హెడ్స్, ఒక హెడ్ ఉండాలి. ఒక హెడ్ ఉన్నటువంటి ఎన్ని ఉన్నాయమ్మా? పైన 2 ఉన్నాయి. HT or TH అవుట్ ఆఫ్ 4 శాంపుల్ స్పేస్. సో దట్ ఇట్ ఈస్ 2/4 అంటే ఎంత? 1/2 ఓన్లీ. P of X ఈక్వల్ టు 2 నెంబర్ రావడానికి P of HH అంటే ఏంటి? ఒకటే ఉంది అందులో పైన. సో H 1/2. దిస్ ఈస్ కాల్డ్ యాజ్ ద ప్రాబిలిటీ ఆఫ్ ద థ్రోయింగ్ ఆఫ్ 2 కాయిన్స్ అని పిలుస్తాం. అమ్మా
P of X ఈక్వల్ టు 0 దానికి P of TT కి టెయిల్ రావడానికి 2 ఛాన్సెస్ ఉంటాయి కదా సార్? 1/4 అని ఎలా సార్?
అమ్మ టెయిల్ అంటే 0. టెయిల్ అంటే హెడ్ ఉందా? లేదు కదా?
లేదు సార్. లేదు.
దానికి ప్రాబబిలిటీ కావాలంటే ఫేవరబుల్ కేసెస్ బై ఎగ్జాక్టివ్ కేసెస్. అటువంటివి టెయిల్ ఎన్ని ఉన్నాయి? ఒకటే ఉంది. 1 డివైడెడ్ బై మొత్తం ఎన్నిట్లకి వెళ్ళి మీరు కౌంట్ చేస్తున్నారు? 4 ఇట్లో. కాబట్టి 4 1/4 ఉంది. ఓకేనా?
ఓకే సార్.
అలాగే X ఈక్వల్ టు 1 అంటే ఒక హెడ్ ఉండడానికి. అప్పుడు P of TH ఒకటి ప్లస్ P of HT ఒకటి. ఆ రెండిట్లో TH లో కూడా ఒక హెడ్ ఉంది, HT లో కూడా ఒక హెడ్ ఉంది. అంటే 1/4 ప్లస్ 1/4 2/4. 2/4 అంటే ఎంతమ్మా? 1/2. అంతేనా?
అంతే సార్.
నెక్స్ట్ P of X ఈక్వల్ టు 2. 2 హెడ్లు ఉండాలి. 2 హెడ్లు అంటే HH మాత్రమే. HH ఉన్నటువంటి మొత్తం ఎన్ని ఉన్నాయి? 1. మొత్తంలో 4 కాబట్టి 1/4. 1/4 అందులో ఎన్ని ఉన్నాయి? 1/4 ఓన్లీ ఆన్సర్. కింద అది 1/2 కాదమ్మా, అది 1/4. కరెక్షన్ చేసుకోండి. P of X ఈక్వల్ టు 2 ఈక్వల్ టు అది 1/4 అమ్మ. కరెక్షన్ చేసుకోండి. ఇస్ ఇట్ క్లియర్?
ఓకే సార్.
Next, if the two coins, if we can toss a pair coin thrice. Thrice అంటే ఏంది? మూడు కాయిన్స్ త్రో చేస్తాం.
Excuse me, sir.
Ah.
Speak in English.
Okay, fine. Here I am tossing of a pair coin thrice. 3 times I am tossing. At 3 coins I am tossing, throwing. At the time I can get the possibilities. One on that here, one head, another on that head, another on that head. That is a one possibility. Next is a one on that head, another on that head, another on that tail. Similarly, if we check, I can get the possibility of sample spaces HHH, HHT, THTH, THH, HTT, THT, TTH, TTT. This is called as a total sample space. How many sample space? 2 power 3 and 8. 8 samples are there. Yes. HHH is a 1, HHT is a 2, HTH is a 3, and THH is a 4, HTT is a 5, THT is a 6, TTH is a 7, TTT is a 8. So here I want that is a head. Getting of head is a probability I want. So here, what is the heads? HHH is a 3. That is called as a range number. HHT, how many H's we have? 2 H's. That is how many we have in a total? HHT and THH. So here HHT is a 2 and HTH is a 2 and THH is a 2. This is also 2. Next, XHTT is a 1, THT is a 1 and TTH is a 1 and the TTT is a 0. So number of heads is I am counting. That is called as a range. If you check that is I have only numbers are the 0, 1, 1 and 2 and 3. So 0, 1, 2, 3 are the range. That is called as the random values. In that random variable values, getting of x equal to 0. X equal to 0 means all tails, TTT. How many we have? Only 1 out of 8. So that 1 by 8 is the probability. Next, coming to that x equal to 1. X equal to 1 means here I want only one head. What are the possibilities? We have a HTT is we have a one head. THT we have another head. TTH also another one head. So if I take one head is a probability is 1 by 8. Another head is 1 by 8. Another head is 1 by 8. Total is 3 by 8 is the probability. X equal to
Hello.